In this segment, we'll cover the SR20's main display features and show you how they help make line tracing fast and efficient. Let's start with a look at how the receiver picks up signals from a target utility. In this sample circuit, a transmitter is directly connected to the utility. When the transmitter is activated, it generates an alternating electrical current that flows through the conductor and back to the transmitter through the earth ground. This current flowing through the conductor produces an electromagnetic signal that can be detected by a receiver. When designating a utility's position, it's important to understand that the receiver is actually tracing this signal and not the utility itself. You are assuming that this signal accurately indicates the utility's location below ground. In favorable conditions, this is generally true. Quite often, however, conditions exist that interfere with or distort the signal, which can make the signal readings less reliable. Some common sources of distortion are signal bleed onto adjacent conductors, turns, tie-ins, and large metal objects such as manhole covers, vehicles, and fences. The SR20's 5 main signal readings help you spot signal distortion quickly. Because all 5 readings are available on screen while you locate, you can quickly compare them to determine whether or not the signal is reliable. Let's take a look at these signal readings and see how they work. We've connected a SeekTech ST33Q line transmitter to the tracing wire for a gas line, and we've set its frequency to 8 kHz. Our technician will position himself near the target utility, and we've marked the utility's position to make it easier to see. His receiver is on, and it's set to 8 kHz active line trace, so let's look at his display. We'll start with the tracing line and the left-right guidance system inside the active view area because you'll use these most often when tracing a line. The tracing line represents the signal's estimated location and direction relative to your position and operates independently of the other display elements. The tracing line makes it easy to acquire the target signal. Simply move the receiver until the tracing line is centered on the crosshairs. The tracing line tracks the signal in real time. You can move to the right, to the left, and even rotate the receiver, and the tracing line will continuously track the signal's estimated position and direction. The tracing line also helps you see signal distortion. Here's how it works. The tracing line's position and direction is based on the angle of the signal passing through the lower antenna, and its sharpness is based on the angle of the signal passing through the upper antenna. If the signal looks the same to both antennas, the tracing line will be sharp. But if the upper and lower antennas see the signal differently, the tracing line will appear fuzzy or distorted to warn you. Next, we'll look at the left-right guidance system. This display element is independent from the tracing line and has 2 parts, the guidance arrows and the guidance line. When you move the receiver across the signal, the guidance arrows track the signal in real time, pointing in its estimated direction. And when you're directly over the signal, the arrows will point inward to the center of the display. The guidance line serves 2 functions. First, it's a visual aid that helps you see where the guidance arrows place the signal's estimated position. Its second function is to help you align the receiver with the signal, because unlike the tracing line, the guidance arrows are measured with highly directional antennas that are most accurate when they are aligned with the signal. The guidance line changes length to indicate your alignment. It will be longest when your alignment is best, and will shrink as you become less aligned with the signal. When you're too far out of alignment, rotation arrows will appear to help you get the receiver back in alignment. We've seen what the tracing line and guidance arrows are and how they behave, so let's take a look at how you would use them to trace a signal. We'll start by using the tracing line to find the target signal and position ourselves over it. Then we'll align the receiver with the signal. We'll begin our trace by walking in the direction indicated by the tracing line. The utility makes a turn after just a few feet, and the tracing line will reflect that turn by rotating. We'll just keep the tracing line roughly centered and let it guide us around the turn. We'll continue, keeping an eye on the tracing line and guidance arrows. Both should be roughly centered at the same time, and the tracing line should look solid, not fuzzy. Let's stop for a moment and evaluate the signal. Take a look at the tracing line. Is it solid or fuzzy? Are the tracing line and guidance arrows both centered at the same time? Do they track with one another as we sweep across the signal? In this case, the appearance and behavior of the tracing line and guidance arrows indicate that the signal is trustworthy. Now that you've seen the graphical screen elements, let's take a look at our numeric readings, the proximity signal and the signal strength. The proximity signal is based on your distance from the signal source. The shorter the distance, the higher the number. The signal strength indicates the signal's absolute strength. The stronger the signal, the higher the number. Both numbers will be highest when you're directly over an undistorted signal and will decrease as you move away. Keep an eye on the two signal readings as we move to the right of the mark and then to the left. In this case, both numbers decrease when we move to either side and are highest when we're directly over the mark. Because both numbers are highest at the same point, this means they're both locating the signal source at the same topside position. They're also in agreement with the tracing line and guidance arrows, which means that we have 4 separate elements in agreement with one another. That's a good indication that our signal is trustworthy and not distorted. The final item we'll look at is the depth reading at the bottom left of the screen. The depth reading is the estimated distance from the lower antenna housing to the signal source. The reading will be lowest when you're directly over an undistorted signal, with the receiver held vertically and the lower antenna resting on the ground. The depth reading is a useful tool for evaluating locates, but the only way to verify the utility's actual depth is to physically expose the line.